Hello, welcome to the fifth lab you'll be doing for Physics 185. Today's lab is going to show you how we determine the actual sizes of objects based on their apparent angular size in the sky. The important thing you'll need to remember in this particular lab is that the math is actually quite simple. If we know the angular size, we can find the actual size by just taking that angular size multiplied by the distance to that object. There's a little bit of a caveat here, though, in that we need to measure the angular size with the appropriate units, and those appropriate units are radians. Unfortunately, when we're dealing with objects that typically have a very small size, or an object that you might see in the sky, the usual measurements that we use to measure their angular size are actually more like arc seconds. And so what we need some small conversion factor whereby when we make the angular measurement in arc seconds, we then have an easy calculation to help us determine the actual size. So all we really need to do is convert from radians to arc seconds in this particular equation. And the equation that we would use in that case would be, we take the angular size measured in arc seconds and then multiply it by 2 pi over 360. That's a conversion that takes us from radians to degrees, and then multiply by 1 over 3,600, which is the conversion that takes us from degrees to arc seconds. And so this will be the equation that you will use to find the actual size of the object if you know, and then of course we can't forget the distance measurement, if you know the distance to the object and you've measured the angular size in arc seconds, using this conversion factor will give you the actual physical size of the object in its characteristic. So the first part of the lab that you're going to do is going to be just a little bit of practice with the math. You will get a picture that shows the angular spread of a planet, and you'll be told how far that planet is away from you. And so to calculate the actual diameter of the planet in kilometers, you would use this angular size in arc seconds. You would use the equation that we had previously put up on the board that takes the arc seconds, converts it to radians, and then multiplies by the distance to get you the actual diameter of the planet in kilometers. You'll check your answer. If your answer is correct, you can go on to a new question. If it's incorrect, you need to double check the work that you did to calculate that diameter. You need to do 5 of these practice questions, and please show your work for all 5 of those questions. Once you've had practice with the math, you're now actually ready to make some real angular measurements. And so you will go to this field of view that gives you a telescopic view of the sky. In this view of the sky, you will see a planet, and you will see a little tiny dot moving around the planet, which represents one of its moons. What you are going to measure in this lab is the angular size of the planet, the angular size of the moon, and the actual angular size of the moon's orbit. And from that, you will be able to determine the physical diameter of the planet, physical diameter of the moon, and the actual size of the moon's orbit. To make the measurements, I'll show you a demonstration for the planet. The same techniques would be used to measure the moon and its orbit. Notice some controls here. You have controls to move your telescope. The coarse control will move it in big jumps. The fine control will move it in small jumps. You can adjust the magnification for your field of view, and then this will give you the coordinates of the crosshairs on the particular screen. If you are measuring the values for the moon, you will probably need to stop the animation because the moon will be moving very quickly. And when you're measuring the parameters of the orbit, make sure your moon is at its most farthest point when you stop the animation to make the measurements. Let's look at how we measure the diameter of that planet. I'm going to center the crosshairs as much as I can now on the planet, and then I'm going to jump to this maximum magnification. I'm going to move the telescope around just a little so I can see the full view of the moon, and I'm going to show the grid to help you guide the motion of the moon in the sky. To measure the diameter of the planet, what I am going to do is I'm going to move the crosshairs so that those crosshairs line up with one edge of the moon as best you can. Right now, this tells me the azimuth for this particular side of the moon is located at 0.266 seconds of arc. So that would be its coordinate. Then I'm going to move these crosshairs to the other side of the moon. And center those on the other side of the moon as best I can. And notice that now the azimuth coordinates is a negative 0.26 arc seconds. To find the difference then, or the actual angular diameter, I would take the difference between these two. So I'd have 2.266 minus a negative number, and remember that would give me roughly double, since these numbers were about the same, about 0.52 arc seconds for the diameter of the moon. So this is how you would find the diameter of the planet. You'd repeat this process for the moon, you'd repeat this process for the orbit. The check your answers box here asks you to do three things: to put in the angular diameter of the planet in arc seconds, the angular diameter of the moon in arc seconds, and the angular diameter of the orbit. And then you won't actually get the distance that you need to do these calculations until you go to the check your answers box, and notice they then give you the distance of this planet from Earth. And then you can use that to determine the diameter of the planet, the diameter of the moon, and the diameter of the orbit. The optional calculations that you need to do down here, you do not need to complete those for this particular lab. We'll look at calculating the orbital period and the mass of the planet at a later lab in the semester. Good luck with the lab. If you have any questions, please email me.